Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. NASA's Juno mission to the gas giant Jupiter is again putting to the test the standard theory of our solar system's formation and history. In recent days, science news reports have remarked on the probe's images of Jupiter's North Pole. On September 2nd, principal investigator Scott Bolton said of these images, "First glimpse of Jupiter's North Pole, and it looks like nothing we have seen or imagined before." In this episode, physicist Wal Thornhill begins our analysis of the Juno mission with a comprehensive juxtaposition of the electric universe theory of planet and star formation versus that of institutional science.
NASA's Juno is the first spacecraft to orbit the gas giant planet Jupiter since the Galileo spacecraft in 2003. Being the largest planet in the solar system, theory says that Jupiter formed first at roughly the distance from the Sun that we see today. The giant planet should therefore retain information about the earliest times in the history of the solar system. So, is it composed mostly of hydrogen and helium like the Sun, or does it have a rocky planetary core? Juno's elliptical orbit will carry the spacecraft swiftly above the planet from pole to pole, measuring Jupiter's powerful gravitational and magnetic fields and atmospheric water content. The Juno spacecraft was sent with the traditional blessing that it would help us to understand the formation of the planets and our solar system. But is a mere belief in a centuries-old theory preventing understanding? The same benediction has accompanied almost all deep space missions, but the results have generally been mystifying. Understanding still eludes scientists. And now, with thousands of exoplanetary systems for comparison, the mysteries have deepened. Our solar system seems an oddity. Some exoplanets orbit backwards, others orbit over their stars' poles, and large numbers of giant exoplanets dubbed hot Jupiters have been found orbiting their stars extremely closely. According to sacred cosmology scripture, they can't have formed there. Intense stellar winds from their new formed stars should have blown the dust and gas out of the inner regions of those exoplanetary systems. The old theory of planet formation from a rotating disk of dust and gas about a star has failed. Thousands of exoplanetary systems show there isn't a workable model. Gravity is the most ineffectual force in the universe to gather dust and gas spread thinly through the vastness of space. Plasma cosmologists have shown experimentally, and the Herschel Infrared Space Telescope has confirmed, that stars are formed along cosmic lightning bolts inside molecular clouds, like pearls along a glowing necklace. What's more, plasma scientists have shown that the heavy elements concentrate towards the centre of the filament, with hydrogen and helium outermost. Stars must have planetary cores, and smaller planets must also form along those cosmic lightning bolts. The electric universe explains that stars are essentially a low-pressure electric discharge phenomenon focused on a large planetary core. In addition, electrogravity provides a very effective long-range capture and orbit stabilization mechanism, so that when the electrical umbilical cord moves on, charge exchange between nearby bodies during close encounters serves to form the weird exoplanetary blended families. The close-orbiting hot Jupiters and moons of giant planets are a result of subsequent electrical discharges of the larger bodies to achieve electrical and orbital stability in a rapidly changing electrical environment. In an electric universe, stars and planets are formed separately in the same electrical event. Each celestial body then has its own unique history. Jupiter and all of our gas giants were later captured by the Sun in separate episodes. That is why they are so very different. So the data from the Juno mission will not show any clear relationship between Jupiter and the Sun, or Jupiter and the Earth. There are gaping holes in basic physics that must result in misinterpretation of the valuable data returned by Juno. Indeed, there is a monumental task ahead for scholars, once those holes are plugged, reinterpreting the mountains of data we are being buried beneath. The gravitational constant includes the dimension of mass, which, according to E=mc², is an energetic variable. The most profound outcome for astronomers is that the gravitational constant measured on Earth cannot be used to calculate what Jupiter or any other celestial body is made from, because it cannot tell us how much matter is in that body. And with no material explanation of gravity, why matter attracts other matter, theorists cannot simply apply our experience of gravity on Earth to the interior of a planet. The electric universe explanation for gravity in terms of the electrical structure of subatomic particles has gravity a dipolar force like magnetism, which can repel as well as attract. This has profound consequences for cosmology and the interior structure of all celestial bodies. Dave Stevenson, Professor of Planetary Science at Caltech, leads the group working on the planet's interior. He hopes to answer these questions. Does Jupiter have a core? What does the structure of Jupiter tell us about how it formed? Where is the magnetic field produced? How far down do the strong winds extend? As a result of its electrical birth, Jupiter has an interior of heavy elements. There is no supercompressed metallic hydrogen at Jupiter's centre or helium rain. Measurements of Jupiter's gravitational field cannot tell us what it is made from, because the gravitational mass is not a measure of the amount of matter in Jupiter, and the internal structure of Jupiter will be deduced from an invalid theory of gravity and gravitational accretion. So be prepared for surprises. Planetary magnetic fields are attributed to mysterious activities in the interior of planets, which have never satisfactorily explained all the observations. A rotating charged body produces a dipole magnetic field, but you won't see any mention of that because astrophysics doesn't deal with electricity. The remarkable strong winds on the outer planets are driven not by the sun's feeble heat at that distance, but electrically, like the Earth's high-level trade winds, by energy tapped from the solar circuit and connected via the conductive plasma in the magnetosphere and ionosphere of the planet. So I don't expect Jupiter's strong winds to go very deep. Ed Stone of Caltech, Senior Advisor for Science and Management of the Juno mission, said, "Jupiter probably formed before the other planets and controlled the architecture of our planetary system through its gravity. The way in which it formed will help us understand how planets in general form. And last but not least, it may even have controlled the delivery of water to Earth, and thus affected the environment of our home planet. Also, Jupiter's magnetosphere, the region occupied by Jupiter's magnetic field, is the largest object in the solar system. Its radius is larger than the Sun. The magnetic field is responsible for Jupiter's aurorae." Now, Space Telescope infrared images pierce the dust of dark molecular clouds and show that the old story of a star and its planets forming from a disk of dust and gas is wrong. Forget the bedtime story of the clockwork planets being born somehow and orbiting the Sun for billions of years like we see today. The origin of the Earth's water oceans presents an enigma for astronomers. Being crucial for life as we know it, water is sought on every body visited in the solar system. The problem is why the Earth has any, because the early Sun should have blown the light gases, hydrogen and oxygen, out of the inner solar system. Only the reconstruction of recent events in the solar system involving the Earth can provide a simple, testable answer to the origin of our oceans. Jupiter does not hold the key to Earth's water. Jupiter was here long before the Earth arrived. Jupiter's gigantic magnetosphere, larger than the Sun, is mentioned with no understanding that it defines the electrical domain of the planet, its plasma sheath. Jupiter's magnetosphere is not a cause of the planet's powerful aurorae. The aurorae are produced, just as on Earth, by electric currents flowing in a circuit that includes the Sun. As an important side issue, if Jupiter and its moons were an independent system in interstellar space, then that huge magnetosphere or plasma sheath would glow red in the galactic circuit, and Jupiter would be classified a brown dwarf star. The inner moons of Jupiter would bask in the enveloping warm glow of that plasma sheath. It's the ideal location for life to exist, and it makes the proposed mission to Europa more important than presently understood. Andrew Ingersoll, Professor of Planetary Science at Caltech, is head of the Juno Atmospheres Working Group. He notes, Jupiter is the largest planet and it comes closest to having the same proportion of chemical elements as the Sun. Also, it is like a fluid dynamics laboratory where storms last for decades and the planet's rotation steers the winds into multiple jet streams. With Juno, we would like to determine the average water abundance of the deep atmosphere. This question bears on the oxygen to hydrogen ratio on Jupiter compared to the ratio on the Sun. The ratio is fundamental to how the elements were distributed through the early solar system and how Earth got its oceans. It's disingenuous to simply state that Jupiter comes closest to having the same proportion of chemical elements as the Sun. All we can measure are the very tops of the atmospheres of both bodies. We should expect significant chemical and isotopic differences because Jupiter had a separate birth and history before capture by the Sun. Also, I expect Juno to find the differences to be more evident since the Sun has nuclear reactions taking place continually in the electric discharges of its photosphere. Jupiter's atmosphere is not simply a fluid dynamics laboratory. It is an electrodynamic plasma laboratory. This is an abiding fundamental error of electrically sterile planetary physics. The comet Shoemaker-Levy 9 fragments did not explode in Jupiter's atmosphere. They were destroyed before entry in unexpectedly brilliant outbursts in the ionosphere. The characteristic plasma gun dark fallout rings seen on Jupiter confirmed that. So the electrical energy that powers the jet streams and the great red spot maelstrom is available from Jupiter's ionosphere, not the interior. There must be some electrically significant surface feature beneath the great red spot, acting like a massive lightning conductor. I expect Juno to encounter electromagnetic and particle disturbances high above the great red spot. As for the water abundance on Jupiter, it has no relevance to the Earth or the formation of the solar system. The Sun's entire family is adopted. Look to Saturn, its icy rings and moons, for our water source and familial similarities. To sum up, the aims of the Juno mission to Jupiter are based entirely on a single misguided idea of how the solar system formed and remained much as we see it today. So I guarantee that all we will end up with are more mysteries that will require more vast sums for space missions, with the unfulfilled promise that they will help us understand the formation of the solar system.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Science.
NASA's Juno is the first spacecraft to orbit the gas giant planet Jupiter since the Galileo spacecraft in 2003. Being the largest planet in the solar system, theory says that Jupiter formed first at roughly the distance from the Sun that we see today. The giant planet should therefore retain information about the earliest times in the history of the solar system. So, is it composed mostly of hydrogen and helium like the Sun, or does it have a rocky planetary core? Juno's elliptical orbit will carry the spacecraft swiftly above the planet from pole to pole, measuring Jupiter's powerful gravitational and magnetic fields and atmospheric water content. The Juno spacecraft was sent with the traditional blessing that it would help us to understand the formation of the planets and our solar system. But is a mere belief in a centuries-old theory preventing understanding? The same benediction has accompanied almost all deep space missions, but the results have generally been mystifying. Understanding still eludes scientists. And now, with thousands of
On September 2nd, Principal Investigator Scott Bolton said of these images, "First glimpse of Jupiter's North Pole, and it looks like nothing we have seen or imagined before." In this episode, physicist Wal Thornhill begins our analysis of the Juno mission with a comprehensive juxtaposition of the electric universe theory of planet and star formation versus that of institutional. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. NASA's Juno mission to the gas giant Jupiter is again putting to the test the standard theory of our solar system's formation and history. In recent days, science news reports have remarked on the probe's images of Jupiter's North Pole,